Assalamualaikum and very good day. My name is Mohammad Sahrudin bin Mohammad Sani from UTM Space Kuala Lumpur. First of all, I would like to say thanks a lot to panel because willing to spend some time for our session today. I'm going to start with title of research, which is Optimization of Proton Saga 2016 Doctrine Design, including side impact analysis. For your information, this research was done in collaboration with DreamEdge Sendirian Berhad. So DreamEdge Sendirian Berhad is an engineering consultant and services company located at Cyberjaya, Selangor. This slide show our agenda for today. We will start with introduction, followed by research methodology. Then we will continue with modeling and testing setup, simulation setup, data collection, result and discussion, and the last one is the conclusion and recommendation. So based on Asian Automotive Federation recorded that car sale in Asian region is keep increasing. In 2017, it is about 5% increase, which is up to 3.5 million units. And beside that, we also have a data from Malaysian Automotive Association, which is the private car registered is up to 400,000 units as of September 2019 in Malaysia. There are so many car segments nowadays. The most popular car segment in Malaysia was A segment, B segment, C segment, and D segment. Last but not least, SUV segment also is keep increasing in market demand recently. So the data from the Road and Safety Department said that it is about 550,000 accidents occur in Malaysia. From the value, about 6,700 accidents was fatal injury. Besides that, the news reported that Mr. Kevin C. Fogg from Law Office UK said that 25% of car accidents involve a side impact collision. So as we can see here, this is the general record of the road accident statistic in Malaysia from 1997 to 2017. So based on the data here, we can see that the accident keep increasing every year. So based on that condition, car component need to build with the high safety criteria, but not to forget about the optimization of engineering design. We continue with the methodology of the research. So before we start the research, we are study to understand the concept of optimization of the car door trim. And beside that, we are also study from the previous researcher to identify the parameter that involved with the car door trim. And after make some study, we are successful to determine the significant parameter, which are divided into three criteria. The first one is the part thickness, number two is number of fastener, and the last one is the thickness of flange grip. So after identify the significant parameter, the next process is to measure the standard range of significant parameter. So this activity was run with the variety of the car, but in the segment, the same segment of the car, which is B segment car, such as Honda City, Toyota Vios, and also Mazda 2. So from this methodology, we will cover the first objective of the research. And after that, we continue with the design of experiment and run the simulation of the impact analysis by using the NX-CAE software. And after finish the simulation, continue with the data collection. So the data collection was divided into two criteria. The first one is the door trim displacement result, and the second one is the door trim stress distribution result. Then after get the simulation result, we continue with the ANOVA analysis, which is to optimize the significant parameter by using the design expert software and also the NX software. So after that, we will continue to create the engineering design 3D data by using the CATIA software. So the engineering design 3D data uh, in the real industry will provide to the production team to produce the mass production for the end user. Next slide is the modeling and test ring setup. So before we start the study, we need to identify the range of perimeter of the significant parameter. So we have the three main significant parameter, which is the part thickness, number of fastener, and flange rib thickness. So after we identify the range, we continue with the experimental metric design. So based on the table here, the total run that we need to do for the simulation is about 17 runs. So after make the metric design of experiment, we come out with the 3D data CAD design of the car door trim. So the slide here show the significant parameter was located. The first one is the part thickness of the car door trim. The second one is the fastener around of the door trim, and the last one is the flange rib. So in this research, we are focusing the flange rib at the middle of the car door trim. So we continue with the simulation setup. So for your information, simulation setup, we are using the software called NSYS, which is the CAE software. So we need to open the software and load the 3D data and continue with the 3D data meshing process, and we apply the fixed point, apply the force about 2000 Newton, and after fix the perimeter, we run the simulation and we extract the displacement result and also the stress value result. So after finish the simulation, we make a data collection. The first one, as we can see at the left hand side here, this is the displacement result for the value of the part thickness 1 millimeter, number of fastener 4 pieces, and the rib thickness 1 millimeter. So based on this value, the displacement was recorded about 23.4 millimeter. And we can see at the right hand side here, displacement result for the value of the part thickness 4 millimeter, mounting 10 pieces, and the rib thickness is 1 millimeter. So based on the value here, the simulation recorded the displacement of the car door trim is about 1.32 millimeter. So this is the smallest displacement recorded for the simulation. As we can see in this table, this is the displacement result from our 17 runs in total. And beside that, we also got the stress distribution result from the CAE analysis. So we can see at the left hand side here, for the part thickness 1 millimeter, number of fastener 4 pieces, and rib thickness 1 millimeter will produce about 32 megapascal of the stress. And the result was different based on the value variety of the simulation. As we can see at the right hand side here, the part thickness is 4 millimeter, number of fastener 10 pieces, and the rib thickness is 1 millimeter. And from this value, the stress distribution was produced around 2.7 megapascal only. So this is the result of the maximum stress distribution of the car door trim based on our simulation before. So the result and analysis discussion. So after finish the simulation, we continue our research with the box Bacon analysis. So from the box Bacon analysis, we will get the two final equation. The first one is the chorded factor, and the second one is the final term of actual factor. Right. So as we can see here at the left hand side, show the normal probability plot of residual and residual versus predicted plot. So at the left hand side, determine the data error are normally distributed along a straight line. So based on this condition, we can prove that there are no occurrences that affected the data. Meanwhile, figure at the right hand side show the data randomly scattered, and it is shown that there is common structure appear and the model is satisfied the prediction. Okay, we continue with the predicted vs actual. So as we can see here, the predicted versus actual plot uh, was recorded the linear line. So this is the acceptable result of the simulation. Okay, the next slide showed the box Bacon analysis. We can see the part thickness was 4 millimeter, number of fastener is 5 pieces, flange rib thickness is 0.52 millimeter, and all the value will produce the displacement about 0.47 millimeter only. As for your information, this value was get from the optimization process during box Bacon analysis. We continue with the theoretical analysis. As of previous slide I show before, this is the displacement result is about 0.47 millimeter by theoretical analysis, which is the box Bacon analysis. So in order to prove the result is acceptable, we run the same value of significant parameter in CAE simulation analysis, and we got around 0.49 millimeter displacement. So this is recorded that there is an error which is around 4.26%. So this result is acceptable since it is below than 5% error. Okay, we continue with the conclusion. So based on the research, we successful to identify the significant parameter of car door trim, which is part thickness, number of fastener, and flange rib thickness. So the optimization process will taken place based on the CAE simulation result, which is we are using the NSYS CAE software. So the optimization of door trim significant parameter was done by using the box Bacon analysis. Then after we get the optimization significant parameter value, lastly we will create the 3D data engineering design, which is to provide to the production team to produce the mass production for the end user. So the conclusion is minimum displacement of the Saga 2016 door trim. We are decided to have the part thickness of 4 millimeter, number of fastener 5 pieces, and flange rib thickness 0.52 millimeter. Right, we continue with the recommendation for the further research. The first one is the material selection of the car door trim. As we know that there is so many material variety in the market nowadays. And the second one is the costing of car door trim. As we can see, there is every cent that invest in development need to be count as the cost of production. So that's all from me. Thank you so much.